All right, problem 7. We have that at a baseball game, 42 of 65 randomly selected people own an iPod. At a rock concert occurring at the same time across town, 34 of 52 randomly selected people own an iPod. A researcher wants to test the claim that the proportion of iPod owners at the two venues is different. A 90% confidence interval for the difference in population proportions, game minus concert, is negative 0.154 to 0.138. Which of the following gives the correct outcome of the researcher's test of the claim? Okay, so let's go through each of these. Because the confidence interval includes 0, the researcher can conclude that the proportion of iPod owners at the two venues is the same. No, this is actually be the opposite. This is definitely wrong. Since it includes 0, we could 0 is a plausible value, and we could actually say 0 is the true difference, and then meaning that there is no difference in the proportion of iPod owners in the two venue groups. So let's look at B. Because the center of the interval is negative 0.008, the researcher concluded that the higher proportion of people, doesn't matter what the center actually is. Don't think that the center of this of a confidence interval, it doesn't mean that that's more likely, and it doesn't mean that the values at the end are less likely. Every single one that's captured, it doesn't work that way. It doesn't even assign probabilities to each value. It's just saying that all of these are plausible values. Every value here, negative 0.154, negative 0.15, negative 0.15, 0. So it's not going to be B. Because the confidence interval includes 0, the researcher cannot conclude that the proportion of iPod owners to the two venues is different. Okay, so this would be our answer. Because remember, 0, that means 0 is a plausible value. 0, it's possible that the true proportion difference is 0. So since it includes 0, it's a plausible value, and then we have some reasonable, confidence that there may not be an actual difference in the population proportions. Right, so don't even really need to check the rest. It's an 8. A simple random sample of size 100 is taken from population A with a proportion of 0.8 of successes. An independent simple random sample of size 400 is taken from population B with a proportion of 0.5 of successes. The sampling distribution for the difference population A minus population B in sample proportions has what mean and standard deviation? Okay, so the proportion the proportion differences, the mean proportion differences to the mean of P A minus PB, which is B. Well, they're all the same, so I mean, I guess it's already, you're not having an issue with that. 0.8 minus 0.5, which is 0.3. Now the standard deviation of the difference, it should be P hat actually, the difference in sample proportions, we're going to use this formula. Pop it out right here. We're looking for differences in proportions, so it's going to be this formula right here. So this will be equal to the square root. We can just, again, we'll call P1 PA since we're doing A minus B. So then we'll have PA hat times 1 minus PA hat over N1, or N is sample size of A, plus the sample proportion of group B times 1 minus the sample proportion of group B over the sample size of group B. So then this will be so for population A, be 0.8 times 1 minus 0.8 or 0.2 over 100 plus for population B or group B, the proportion is 0.5. 1 minus 0.5 is the same thing, so 0.5 times 0.5 over the sample size of group B over 400. So if you do the math, you do it correctly, you should get square roots. For this group, you should get, let's see, about 0.0016 plus, I just did it right here, plus 0.000625. This is just the algebra part, so you shouldn't have issues with this. You never know. And taking the square root, you get about 0.047. And so the answer will be E or C.